This is a video about number 13 from the first homework. I think it's section 1.1, I think. Could be wrong. Yeah, section 1.1. And it was about a comment that I made in office hours. And so in the problem, more or less, if 1 plus root 2 is a root of this quadratic equation, x squared plus bx plus c equals 0, does the other root have to be 1 minus root 2? And what I was trying to say in office hours is, no, the other root does not have to be this one. So how come? Why? So by the quadratic formula, if I know that 1 plus root 2 is a root of this, then absolutely we can set 1 plus root 2 equal to minus b plus square root of b squared minus 4c over 2. And if I split that up a little bit, I could say, just split this fraction into two pieces. So what I was trying to emphasize in office hours is there should be infinitely many choices for b and c here. If you include all real numbers, there's infinitely many choices that could make this particular equation true. And equivalently, there should be infinitely many quadratic equations that have 1 plus root 2 as a root. Or in other words, there should be infinitely many parabolas that have 1 plus root 2 as a root. And so to demonstrate that to you, I made a little thing on Desmos, so you see this now. And I made a slider, so the green point is 1 plus root 2 on the x-axis. And so the point of this slider is to demonstrate to you is there's not just one parabola that goes through that green point. There's a lot. So in other words, there's infinitely many quadratic equations that have 1 plus root 2 as a root. Now let me go back to the problem. So one option, which is what many of us did, is why don't we make like a system of equations where why don't I say, well, minus b over 2 probably has to be what 1 is, and so this radical nonsense has to be this radical nonsense on the right side. And so if I set up that system of equations, when I solve it, I get b is negative 2 and c is negative 1. So if you plug those in, your quadratic equation is x squared minus 2x minus 1, which happens to be what you'd get if the other root was 1 minus root 2. I guess, where is that at? I think I should have put that, oops, I didn't factor that right, did I? So I think I should have minus 1 minus root 2 there. There we go. So that's how that one would factor. So it just happened that when you solve the system that way, in other words, when you make these choices for b and c, that's when you get what some of us thought was the more intuitive idea, that if 1 plus root 2 is a root, then sure, it's possible that 1 minus root 2 is another one. But again, just to go back to Desmos, I'll plot that one now in blue, and my point is that that blue parabola, that's not the only one, again, that has 1 plus root 2 as an x-intercept, right? There's still a lot of them. So what we just did is we just picked out one of them.